Okay, so we are, to me, this is the unit that I love the most. This is the unit that really will take your algebra skills to another level and be able to get you to be quite successful when you're in your 30 levels, both 30 and 31, because up to now, we've been always solving for one variable. Like, you know, if I said y, or 2x equals 8, okay? And so I would divide by 2, x equals 4. Okay, do you see how there's only one solution for that? Okay, x equals 4. That's it, right? But what if you're doing x plus y equals 8? There's over a trillion different combinations that will work. Okay, I mean 2 plus 6, 1 plus 7. How about, you know, 9 plus negative 1? I mean, we just go on and on and on, right? If you have one equation with two unknowns, there's infinite. But if you have two equations and two unknowns, you're back to one answer. And if you have three unknowns, x plus y plus z equals 8, now you've got trillions and trillions again. But if you give me three equations with x plus y, z in it, then there's only one answer. Okay? And that's called a system. A system is, if you give me two unknowns and one equation, there's millions of answers. You need to give me two equations if there's two unknowns. And you need to give me three equations if there's three unknowns. And you need to give me four equations if there's four unknowns. Okay? That's the only way I can give you one answer. And then we're going to try and do a parallel between, if you give me two equations and two unknowns, how does it look when I graph it? Because what's really cool is with two graphs, where they hit is the answer. Where they intersect is always the answer. So again, I want to try to get you guys encouraged to get that graphing calculator. Okay, this is pretty late in the year not to have one. So that graphing calculator is not just something that you're going to be using this year. It's something by the end of grade 12 you have to have that calculator mastered. Okay? Because you have to be very tech savvy with that calculator. You will be competing against every other Math 30-1 student that knows that calculator well. And knowing that calculator well, they will be able to surpass what you can do. Okay? Because like I've told you before, you can check almost every answer with your calculator, giving you a much better chance of success. So, okay, you'll find the way to get one. Okay, get on Kijiji, get creative, put an ad on Kijiji yourself, looking for a TI 84 plus. Who has one? Okay, and you'll get people that are looking through Kijiji for something else, going, yeah, I got one of those in my drawer. You want it? $10, yours, right? Like they were sitting in the drawer, not even doing anything, right? So if you want one and you don't have the money, you can get one. Okay, if you want, you know, but every day that goes by that you're not practicing on that thing, someone else in here is, and I guarantee you, like, this is the first time in my career that I haven't had a TA84 in every desk, right? Always. So it's something that is rare, but, I mean, you're competing against all those people that have them. Okay, so get on it. Now, we have talked about a linear equation quite a bit. And that is y equals mx plus b. And a linear equation will always be, so that's an equation with degree 1. Okay, and that's what I mean by degree 1. There's a 1 on the x. Okay, I don't know how this got mixed. So someone actually pasted that in there, but they knew it was wrong. Okay, so anyway, now the other thing that we want to just kind of heighten is the English compared to the sign. Okay, now again, math is an extremely efficient language. which is what makes it quite complicated. Okay, now there's a couple ways to say this sign, equal to or equals to, and is the most common. Okay, so example, if a number is 4, you would just go y equals 4. Or 2 plus 3 is 5, is would be the equal sign. Now we've got the plus sign. We've got add to, plus, increased by, more than. One that is missing, that's quite common, is sum. Find the sum of 2 and 4. Now, always remember that you can just say 4 more than a number too. So more than means y plus 4. You got your minus sign, so obviously minus is 1. You take away, decreased, less than, subtract, difference is commonly used for the answer. Find the difference of 8 and 4. Okay, and then 4 less the number. Now make sure that you're putting the number first. Like, this is a common error. 4 less a number. Okay, they read it like that, but that's not 4 less a number. Okay, that's a number less 4. So always make sure that if you're taking 4 less a number, okay, the number, like if it's 20, it would be 16. So it's 20 minus 4, okay? Now division, this probably has the least words for it. Divided by, quotient, ratio is another one, fraction, rational. So the quotient of a number and 4 would be n divided by 4. Okay, multiply, we got multiply times, product, double, triple. Okay, and an unknown number is always going to be a variable. The length is twice the width, all that stuff. Okay, so the reason why we're just reviewing that language is because we're going to work a lot more with it. Okay, now a system of equations is 2 or more equations with 2 or more variables. So a system is a bunch of different things working together. Okay? And in this example, we're talking about equations. So if you have 2 unknowns, you have 2 equations to solve them. So, and like I was saying before, usually the number of variables is equal to the number of equations. Now, the solution to a system of equations is if you give me one line and then you give me another line, that's the answer right there. It's the intersection point x comma y. Now, you'll also see it is the point that satisfies both equations. It's a common point they share. Now a common point they share will be an intersection of them because look, they both share that point. And when you start to see how these work, they're really neat because they're the actual finding like the sweet spot, right? When you're like saying you want to open a gym, what should I be charging for my membership to make the most profit? Okay? And that's not easy. Okay, you may think, oh, $20. Okay? But what if 20 bucks is too low and you've got tons and tons of people, it's crowded, equipment's breaking down, just can't keep up with things, you can't service them, and then, hey, at the end of every day, you're actually losing money. And people are like, but it's packed in here. How are we losing money? Well, because we're not charging enough per person. So then you charge too much. And then you got nobody there. And you're like, how are we losing money? We're charging so much. Well, that's why we don't have people coming. Okay? There's such an art to knowing the right amount to charge for the most profit. Okay? And it's not always what you think. Okay? You may think that charging less, you would make less. That's not true. Okay? Ask Walmart if that's true. Okay? That is how Walmart exists. Because they go into companies, and I mean, if you're a company that's supplying Walmart, they're not very nice. They'll come in and they will tell you exactly how you need to cut corners, because we need 25 cents off every DVD player, every iPad. Like if you check it out, probably the cheapest iPad that you can buy is Walmart, and it'll be $1 cheaper than everybody else, right? But that's off Apple. Apple does not. So Walmart picks up that dollar. So why would Walmart want to like take a debt, right? But they know, okay, if they come to us, they're going to also buy something else maybe, and we'll make profit off that, okay? You know, concerts. How do they know that magic number to charge a ticket? Because some are atrociously high, some are a lot lower, right? They want to sell out for the most money. I mean, that's the perfect storm, isn't it? Right? But how do you do that? You need to do a system. Okay, you need to find maxims. You need to find that perfect point, right? And, you know, it comes down to the math. The math is how it gets done. Okay? There are accountants on this stuff all the time, helping them out. Okay? There's financial planners helping them out, trying to make sure that they're making the most profit. Now, here's an example of just a nice, simple, linear equation, okay, with just one variable, right? One variable. So I got 2x plus 2 equals 14. I'll subtract 2. I've got 2x equals 12. Then I'm going to divide by 2. X equals 6, okay? That's like, you know, one variable, one equation. Okay, therefore, a linear solution with one variable has one solution. Okay, well, let's talk about a linear equation with two or more variables. Okay, this all got squished a little bit. I don't know why. Let's see if I can move this over. Okay, so x plus y equals 6. Give me one. Okay, so 3 would be 1, correct? What's another one? Give me another one. Oh, no. 1 comma 5. 2 comma 4. Okay, it's pretty safe to put a dot, dot, dot. I could tell you you'd spend the rest of your life coming up with all the points. Yes? No, they never have to be. 3 is a point on a graph. Right? This is x, y, right? Think about your graph. We got 3. So we got 2, 4 would be there, 3, right? 4, 2 would be there, so it's going to make that. Yeah, x and y can be the same, absolutely. Okay, now, therefore, oops, we've got like infinite points. Now, so, therefore, an equation with two or more variables has infinite solutions, right? But now let's talk about a system. Which of the following is a solution to y equals 3x plus 5 and 6x minus 5y equals negative 43? Now there's only one answer. Now you're saying, huh, but there's a million answers here for x, y, right? I can put in any x, get out a y, yep. And there's a million answers for here. But together, there's only one answer. And it's the x, y they both share. That's what this is saying. What's the solution? That is saying, which point do they share? Now it's one of these, A, B, C, or D. Okay, I'm going to give you a minute. Okay, see if you can find the one. I'm going to pause the video. Okay, so maybe let's just do this point together. Let's go. Does 8 equal 3 times 1 plus 5? 8 equals 8. Yes. Okay, now I'm going to try it into the, so that's equation 1. If it works for equation 2, then it's good. 6 times 1 minus 5 times 8, does it equal negative 43? 6 times 1 is 6, minus 5 times 8 is minus 40, equals negative 43. Negative 34 equals negative 43. No, obviously doesn't. So this does not work for both of them. Anyone find B to work? B is not working? You can see this one being a nice multiple choice question on a test, right? Yeah? Which one, Raven? Okay, let's try it. 11 equals 3 times negative 2 plus 5. 11 equals negative 6 plus 5. No. Oh, okay. So maybe change yours so it looks the same as mine, or else you're going to be... So we'll try this one. So this is your C, my D. So I'm going to put in 11 equals 3 times 2 plus 5. 11 equals 11. That one works. Let's try the other one. 6 times 2 minus 5 times 11 equals negative 43. Okay, 12 minus 55 equals negative 43. Negative 43 equals negative 43. This is the correct answer. Yep. Okay, but what saves all the work is putting both in your calculator. Okay, so this one's ready to go into our calculator, correct? This one's not, because I got to get it to y equals. So the first thing I'm going to do, let me just write it again. 6x minus 5y equals negative 43. I'm going to minus 6x, right? So I'll get negative 5y equals negative 6x minus 43. And then I have to divide by negative 5. So y will equal 6/5 x minus, plus, that's a negative 5 down there, plus 43 over 5. So if we get our calculator out, then this will help illustrate what I was talking about. I'm going to put them both in. Okay, so I'm going to get my calculator on. Y equals, I'm going to clear that, 3x plus 5. Go down below, I'm going to get y equals bracket 6/5 x plus, I always put them in brackets because then it helps, plus that fraction. Okay, I'm going to go zoom 6. It won't show up, but this is another learning point here. Do you see that it's up here somewhere? Probably where they're going to hit. So if I wanted to see more up there, what do I need to increase? Which one though? My y, but yeah, my y max. What's a good window for y max? Okay, so then you hit your y max and you go to 20, and then you hit enter. Now, the way that you find this point, no. You ready for this? You hit second, trace. Now, which one of these do you think you want? Intersect. So you can go down and hit enter, or you can just hit 5. Doesn't matter. So you hit intersect, and you'll get this spider. Now, when you have more than one intersect today, for us, we won't, but you need to get that spider close, and then you just hit enter 3 times. 1, 2, 3. Boom. 211. Well, this is why, like, there's some students, they're so good with these calculators when they come into their diploma that they're going to find every mistake they made. Okay? So this is your first kind of showing of how you need to have this graphing calculator to be able to compete. Yes? Okay, so you ready? So I'm just going to hit graph again because now it's all gone. Now this, see, what does that say? Right there? Calc. Anything yellow means I got to hit a yellow button first to make it work on my calculator. Okay? So I need to find a calculation here, so I go second trace, which is calc. And then I need to do the intersection of 2 things. So you can hit the number 5 right now, or you could just use your scroll button down and hit enter. But we're all about speed, so I hit 5. Now, my spider is already known to be there already, but then you just hit the enter button 3 times. 1, 2, 3. And it'll give you the answer. Okay? So this is kind of your first, or not the first, but one of the first times that you're seeing the parallel between the picture and the math, the work, the finding it out algebraically. That's the only point they share. When you have a system and you're actually looking for the solution for that system, what point do they share? Okay? Now, when it's 2 lines, will they always share a point? Yes or no? If you're saying no, or you're saying yes, I want to know why. If you're saying no, why? Will 2 parallel lines ever share a point? Okay? How would you know they're parallel? Same slope. Now, can parallel lines have infinite? If they're the same line, right? So if they're the same line and they fall on top of each other, there's 2 lines that share an infinite number of points. If there are 2 lines that are parallel that are beside each other, they will never meet. Never meeting means never a solution. Okay? Meeting means solution, and that's why I put which point do they share. See, where do they meet? Right? And this is stuff that you need to get down on a study sheet. You need to be able to grasp this, right? And you know, my students that aren't putting this stuff into place, they just keep going every day, not seeing the connection, therefore obviously not being able to. Okay? So for a solution to be valid, it must satisfy both equations. So I showed you algebraically. I showed you visually with a picture. Those 2 share a point. They both have 211 on them. It's the only one. Okay? You'll know. Because, well, here's another thing that you can always do. Okay, so here's another graphing tip. So even if you want to keep this straight, you can see how you can go up, down. If you go all the way left, and see how I'm blinking by the, if you hit enter again, it'll be a bit of a thicker line, and that'll help you tell the difference between the two. But what will happen if they were the same line, okay, so let me just clear this, and I'm going to put 3x plus 5 on there. You need to watch the, and I come over here, and I put enter, and it'll graph the first one, okay, and that's your way of knowing they're the same line. Okay, but if they're both the same thickness, you won't know. So those are little tricks you do. And that's another way I can show you later how you can do verification, that if you put in the question of an algebra question or whatever, put that into your calculator. Then put your answer into the calculator that should be the same line. Therefore, okay, so, and I'm always going to, like, and that's why if everybody's got a graphing calculator, we can do these things together, so you can just get better at your calculator, better at getting, you know, on your tests. Are you going to learn how to practice on your quizzes? Right? You get your quiz, you've got it done, can you check it? Okay? So trying to wean you off me, trying to come around and go, yeah, that's right. You should be able to go, I guarantee it's right. I even drew my graph there. There's the picture of it. Okay? So you can solve systems two ways, graphically. And this is going to be, we're going to spend more time on day 2 and 3. And algebraically, day 4 and 5. We've got elimination and substitution. I'm a big fan of elimination, just because it sounds cooler. And to me, it's just, I don't know. I guess, and some people are going to like substitution better. Doesn't matter, right? And when you get good at them, you're like, substitution would be easier on this one. But I find that as they get more complex, elimination works better. Now we're going to start making actual systems. Okay? We're going to make statements that are true, and from that, you can always find out the answer. Now the perimeter of a sheet of paper is 38 inches. The length is 3 inches more than the width. Create a linear system to this model. Now, some of this stuff stresses students out like crazy. And actually, linear systems takes away some of that stress, because in the past, you've had to learn how to put that all in one equation. Okay? Now, we're going to do it with 2 equations, but we want to keep the same variables. Now, for those visual learners out there, we're going to make sure that we just do a little picture of perimeter. And, you know, obviously for this one, L stands for length and W stands for width, but sometimes maybe you're going to call them X, Y, and you might say X is going to be my width, right? Y is going to be my length, whatever. You should tell yourself what they are. Now, let's just do an equation for this one. The perimeter of a sheet of paper is 38 inches. What would be the equation for that? W plus, or we could go 2W plus 2L equals 38. Okay, and then here's where that vocabulary is going to come in. I want another equation for this. The length is 3 inches more than the width. This one you got to think about. Yes, see? Okay. Okay. L equals W plus 3. Now I know what some students are going, no, the length is 3 more. Shouldn't we be adding 3 more to the length? But if we need to make the 2 sides equal, we're going to have to add 3 to the W. Now this may make more sense to you. The length is 3 more. So, or could we just go length minus width equals 3? Does that make sense? Now, do you see how if I added W to this, I would get length equals 3 plus w. Now do you see how I get the same equation anyway? Okay? But, you know, some students, this may make more sense to. Because I know, students are like, no, it says the length is 3 more. You should be adding 3 more to the length. But if I'm trying to make the two equal, 3 plus w equals a width, right? So then I would say go to this one, because some students are just like, they don't, how about length minus width equals 3? Do you get that one? Yeah, that one makes sense. Okay, then use that one. Okay? Now, these are my two systems. Or this is my one system of two equations. Same variables that are, and those sentences must be true. If those sentences aren't true, I guarantee you're going to get the wrong answer. Okay? Now, a student measured the paper to be 11 by 8. Use a linear system found to see if it's correct. So, is 11 by 8 true? Now, today's an introduction, so later we're going to have to find it. But let's just go, now, which one's which? Yeah, because we said that, right? So we can already tell equation 2 is going to work, because is the length 3 more than the width? So we know that one's going to work. Let's see if 2 times w, which is 8, plus 2 times 11, which is the length, equals 38. 16 plus 22 equals 38. 38 equals 38. Okay, now if I wanted to use my calculator, which we're going to get in more detail next day, I could just get them so they're both L equals and solve. Okay, let's keep going. Calculate a linear system to model this situation. The stage at the level of Victor, Alberta, Bonnyville is a rectangle. Its perimeter is 158, and the length of the stage is 31 more than the width. Okay, so this one is a little bit redundant. We just did this one, right? I don't know if we need to do it again. Okay, let's and then we put in 55, 24, and we get it's the same example as the last one. I don't think we need to do it again. Okay, this one is a little bit different. Create a linear system to model this situation. In Calgary, a school raised $195 by collecting 3,000 items for recycling. The school received 5 cents for each pop and 20 cents for each bottle. Okay? Now, a table works well, but you know what? Sometimes tables work worse for some people. I just want you to take 2 minutes. Do it wrong. Who cares? Struggle through this one and come up with 2 equations. And I'm just going to pause this. I want you to struggle through this. Okay. Okay, Zach, give me one of them. Okay. Okay, so we can go, now sometimes I like to kind of keep it really relevant to the question, and why don't we use P and B? Okay, so P will equal pop and B will equal bottle. So give me yours now using those variables. Give me one of them. Okay, now I think that is a very true statement. The number of pop bottles plus the number, or sorry, number of pop plus the number of bottles equals 3,000. Now the other one you're going to find is very standard. You can do this every single time. Yep. Okay, 0.05 P plus 0.20 B equals 195.00. Okay, so and when the more you do, you just see the redundancy, right? But always take the worth of one pop bottle times the worth, or one pop, sorry, plus the worth of one bottle equals your total money. Okay, so the first one I deal strictly with the numbers. The second one I do strictly money. And this, I can't tell you how many different varieties, okay. You know, there was, you know, 25, or no, there's so many junior high and so many high school students went to the dance, and there was 585 people total. And then they'll say they charge each junior high this much, and they charge each high school kid this much, and they made $4,082. Okay? There's another common one, right? Where two different types of people, two different prices, right? So it's the same setup every time. Now, the thing was that they collected 2,700 and pop cans. Yeah, that's what that should say, pop cans. That would be better, hey? C and B. But anyway, 2,700 pop cans and 300 plastic bottles. Use this to verify. Well, my first one is 2,700 plus 300 equals 3,000. Yes. Is 0.05 times 2,700 plus 0.20 times oops. Oops, sorry. Okay, times 300 equals 195. And you'll find that does work. So honestly, if you did not take tally of how many junior highs came, how many, right? But at the end of the day, you knew exactly how many people came, and you know how much money you had. You could figure out, people would say there's tons of possibilities, but there's only one. There's only one possibility for the number of people and the money. If you have both of those recorded, we had 585 people come, and we have this much money, most people would say, oh, there's tons of different scenarios that would work. And the truth is, there's only one. Okay? There's only absolutely one that would work. And that, for most people, that blows their mind, because they're like, that's the last thing that they would expect. They'd expect 5. 5, they'd be like, okay, yeah, I get you 5, right? I mean, at first they were thinking there's 800, right? Now 5, they'd be okay. But if there's only one, in fact, if you even gave a scenario like that and said to any adult that there's only one combination, they would say no, because you could have this, or no, there's only one. Okay, so a store sells wheels for roller skates, packages of 4, and for inline skate, packages of 8. Create a situation about wheels that can be represented by the system below. Explain the meaning. So 8i plus 4r equals 440. What does that mean? What does this mean? 8i plus 4r equals 440. Just got one person that knows what that would mean. Okay, but we've got to be specific, right, to the question. Prashant? Nope. No, it doesn't. Kane? Okay, so this is number of wheels, right? So this is wheels, wheels, wheels. Okay, so a total of 440 wheels were sold. What's I plus R equals 80 then? And again, this is why we have to go through this, right? We gotta know what are they talking about. Yes? Number of packages, yeah, because that's 80 packages. So a total of 80 packages were sold. Okay, so the challenge today is going to be making sure that you are translating correctly. Okay, are you taking all that words, all those things mixed up and making two nice equations? And if they give you equations, can you even tell me what that means in words?